Okay, so now we have the sine rule, and the sine rule is saying to us, um, sine sine of an angle over the side that is opposite that angle. So what does that say? That is saying sine A, so sine of this angle here over this side, over the opposite side opposite. So sin this angle over that side, and it will be sin C, sin C, so sin C of this angle over that side there. Then sine B, this 40 here, over the length of that side there. So we can say that this is the length, it's the length opposite the angle. It's the length opposite the angle. Okay. And at all times, we will always be using 2. So we're going to use either sin A over A equals to sin B over B, or sin A over A with sin C over C, or sin B over B with sin C over C. So what I mean by that is, we'll be able to see when I start doing a sum. So this sum is saying that we must calculate angle A and C as unknown. So how do we write this? We use one known. So firstly, if we have sin A that's known, we have the angle A that's known, and the angle of B A and the side, the length of A that's known. Then we can use maybe, for example, this. We have B, we have angle B, we have that B. So let's do it like this. Let's do it like this. So the formula is sin A over A equals sin B over B equals sin C over C. Okay. So now we first look for the ratios of the fraction that has all these knowns complete. And we see here sin A, angle of A, we don't have. So we can't use this one. But sin B though, we have the B. So we have the B. Then we have the length that's opposite this. These go hand in hand. Okay. So now we know for a fact we're gonna use this one. So sin B over B equal. So now we're gonna use sin A first, because I see now that angle of C is unknown and the side of C is unknown. So we can't do anything with this, because we can't have two unknowns when we want to get one known. And we don't have the angle of A, but we have the length that's opposite that angle. So now we're gonna get the angle A. So we're gonna use sin A over A. So what do we do now? Now we cross multiply to make angle A the subject of the formula. So we're gonna have B sin A over A sin B Sin A equals A sin B over B. Therefore, angle A equals sine second function A times sin B over B like that. Angle A equal. Now we just substitute. So where is this? This is actually small a. That's a small a, small a, small a. So the small a is 20. Small a is 20. Sum of angle B is 40. And then the small b is 30. So angle A equals angle A equals over 30. Angle A equal to 25,374 degrees. Then to get angle C, so we have angle A now that is 25,374 degrees. Now to get angle C, we use the interior angles of a triangle, and that is saying to us, let's do it here. So angle C equals to 180 degrees minus angle A minus angle B equals to 180 degrees minus 25,374 minus 40. And then this will equal 114,626 degrees. So we have angle A and C now. So that's why you must keep in mind that the interior angles of a triangle equals to 180. The sum of all the angles, the interior angles of a triangle equal 180. That's why we can use this formula here. Okay, then they say calculate AB, which is the small c. So now we have angle C, now, and we don't have that one there at the bottom. Then we have some A now. But we're gonna use this one with this one, that one with that one, because you always use the given. So in case you make a mistake getting the angle here, the given will always be constant and will be right. So we're gonna use it with this one here. So we're gonna say sin B over B equals to sin C over C, and then C sin B equals to B sin C, cross multiply, and then small c equals B times sin C over sin B. C equals 30 times sin C, that is 114,626 over sin B, that is sin 40. So small c equals 42,427 meters. this is AB. AB is small c. This here is AB, and opposite sin C is C. That's how we do it. Okay, the next one is saying calculate AC and AB. Now we have two triangles in one. And how we do this is we first we select a triangle to work in. And okay, I see now that I'm going to use the first state in triangle ADC. In triangle ADC, I'm gonna get AC. So we need AC, so I'm gonna use triangle ADC. So firstly, we must get more information because we don't have everything here. We don't have everything here. So what have we learned? The interior angle of a triangle equals to 180. So 180 minus 90 is 90. 90 minus 16 is 74. That means this angle here is 74. And this is a straight line. So 180 minus 74. 180 minus 74 is 106. 106 degrees. And then we can say 106 or 180 minus 106 minus 46. 180 minus 106 is 18. That is 18. So this is 18, 16. Alright, this is 18 and then 16. So this together must give us 34, 34 degrees. The complete sum of that. And we can prove this by saying 180 minus 90 minus 56. So 180 minus, so we're going to use the big triangle now. So 180 minus this 90 minus this 56 must give us this 34 here. And I see that it does. See, this 180 minus that 90 minus 56 is 34. That means that we deduced it correctly. So always when you can get more information, first start like this. First try and get all the information you can. So by getting this extra angles by how we did it now, you're using the rules of the interior angles of a triangle is 180, and then a straight line is equal to 180. Also is sum. This is the rules you must remember when doing this. So in triangle ADC, we need AC. So we must first figure out what is what. So this D goes with this small d there. This C must go with this C there. This angle A is with this A over here. So angle C is opposite of small c. Angle D is opposite of the small d. Angle A is opposite of the length A. So we need length D, and length D, we get by saying sin D over D equals sin A over small a. Sin A over small a. So to get D, we're gonna cross multiply and say D times sin A equals A times sin D. D equals A times sin D over sin A. D equals, so small a is 20, and then angle D is 106, and then sin angle A is 18. Therefore, length D is 20 is 20 times sin 106 over sin 18 equal to 62,214. And it's in meters. And this is AC. Okay, now for AB. For AB, we say, for AB, now we're gonna use triangle ABD. So let's just do this here for space. In triangle ABD. Again, we wanna figure out what is what. So opposite angle, this angle A is this small a there. Opposite this angle D is the small d there. And here is B. So they want AB. AB. AB is D, the small d. So we're gonna say sin D over D equals, equals, see I'm jumping a gun. We are gonna use, triangle ABC because we don't have any knowns for length here inside this triangle. And you can't do anything with no unknowns. So we're gonna do ABC because we have now AC, which is 62,214 meters. That's why it's very important to write down as much information as possible. So this angle C is opposite to this area, which is a C. So this will be angle C now. Angle C, and that will be small c. So now we can use anything else. We have the angle, we don't have this, we want this. So we can use B, so sin B over small b. This will now be the small b. For triangle ABC. Apologies for it being so messy, but okay. Now we cross multiply again. Say C times sin B equal to B times sin C. C equals B times sin C over sin B. This is equal to B is our small b is 62,214 times our sin C. Our sin C is 56, and then our sin B is 90. So 62,214 times sine of 56 sin 90 over sin 90 equals to 51,778, and it's in meters. So remember that you always need a ratio. These are the ratios: sin A over A, sin B over B, sin C over C. You always need at least one ratio that has all of it's given, like here. You need the angle given and the side given for at least one ratio. And then the next ratio, you must at least have one thing and one unknown to be able to get that unknown. You can't have two unknowns here and then one ratio that has both known and then get anything. You must at least have one ratio that's known and the next ratio that has one missing value, because you can't do anything with two unknowns with one ratio that's unknown. Let's do another one. So the first thing we do when we get this, we get our drawing, we must first determine all the all the angles we can inside there. So this angle between this line DB and this line BC is 74 degrees, and this angle B between angle EBC is 66. So we can get this angle inside here by saying 74 minus 66. This is 8 degrees. Then we know that on a straight line it must be equal to 180. So we can say 180 minus this 8 minus that 66 will give us 106 degrees. Then in triangle DEB, it must equal 180 as well, because that's the interior angles of a triangle. So 180 minus 23 minus 8 equals to 149 degrees. Again, on a straight line, it must equal to 180. So 180 minus 149 equals to 31. We can check the 31 by saying in triangle DAB, 180 minus 106 minus this 43 here, and it's going to equal to 31 as well. So now we have collected and determined more information than we had before, and now we start with our ratios again. So the first ratio is they ask for BD. They're asking for BD. So we're gonna either work with triangle ADB or triangle DEB. So we're gonna use triangle ADB. So this is opposite that angle B is opposite that length B. This angle A is opposite this B this angle D is opposite to this length D over there. So always the length is opposite the angle. The small letter is opposite the big letter angle. So this is capital angle D. This is the length small d. This is the angle A. Opposite the angle A is the length of A, which is small a. So where do we go now? We go with our ratios. So we say sin A over A equals sin B over B equals sin C over C. So what I said is you must first determine the ratio that has all the information in, and I see that it's going to be D because we have angle D. Maybe C. There's no C, so this is D. So so we have angle D and we have the length of D. So we have angle D and the length of D. Then we must now get so now we must get PD, and we're gonna use sin A over small a because small a is what we want. We want small a to give us BD. BD is asked. So we're gonna now write it as something like this. Sin A over small a equal to sin D over small d. Cross multiply. If we cross multiply, we're gonna get this. We're gonna get sin D and then D times sin A. Small a equals to D times sin A over sine D. Then substitute small d is 500 and then sin A is 43. Sin D is 31. Therefore A equals to 662,085 meters. And A is dB equal to dB. Now for DE, we must now use triangle. For DE, we must now use triangle DBE. In triangle DBE, so in triangle DBE, so opposite angle E, our small e is there. Opposite angle D, our small d is here. Opposite angle B, our small b is there. So we want small d. So we're gonna write the ratio as sin d over small d like that because we have angle D which is 149 and we don't have small d which we want. We want that small d, and then we need one more ratio, and we need a ratio that's known. So right now we we have the length of dB, so we're going to use E. So we're going to say equals to sin E over small e, because we have angle E, which is 23, and we have the length of E, which is actually now our dB. So we have that one. This is how you must deduce and figure out what you have and what you don't have. So to get this D, we are gonna get D equals to E times sine D. So E times that sine D, and we cross multiply, divided by this sine E. And this is equal to our E, our length E is 662,085 times our sine D. Our sine D is 149. And then our sin E is 23. That means in a calculator we're gonna get 662,085 times sine 149 over sine 23 will give us 872,72 in meters. Okay, this next one, they want SQ. SQ, the length of SQ. But let's see if we can determine more angles, because that's our first step. So here, let's start with this big triangle. So here we have a 90. So 180 minus 90, that's 90, minus 67 means this angle here is 23. Then in triangle SQR, we say 180 minus this 67 minus this 43 equal to 60. That means this here is 60. And 180 minus this 60 gives us 120. So that angle there is 120. And 90, that's 90, minus this 53 means that this here is 37 degrees. It's always to have more information than you need, just in case of anything. Okay, so now we got all the angles that we could ever need for this question. Now, if they want SQ, the length of SQ, we need at least one ratio to have all the information. So so we're gonna use what triangle? If they want SQ, we're gonna use this. So we're gonna say sin S over S. Sin S over S equals to sin R over small r. How did I get that? So this is our angle S over small s. This is our angle R over our small r, because the length must be opposite to the angle. The length is opposite to the angle. So for S, we have the angle S and we have the length S. We have the angle R, but we want that R. We want the small r. So How do we do this now? We're gonna cross multiply again. R times sin S equals S times sin R. And then small r equals to S times sin R over sin S. R equals. Now we substitute. Small s is 179. 179 times sin R, which is 67. And then sin S, which is 60. R equals. So 179 times sine of 67 over sin 60 equals to 190. 190, comma 26. Let's say, see, there isn't a unit of measurement, so we're going to say units. And again, our R is SQ. And this here, our small d our small d here, our small d here is PE. So I got the wrong one. I should have gotten DE. But that's okay because it's the same steps. But let's just add PE here. And then we say in triangle TBE. So we're gonna say, if we want that one, we're gonna say sin B over small b, sin B over small b equals to, let us use this we got now, So we're gonna say sin D over small d. And then we want the small b, so small b equals to d times sin b over sin d. And then let us quickly substitute. Small d is 872,72 times sin b, which is 8 sin 8 over sine d, that's 149. So therefore our b equals to, so 872,72 times sine 8 over sine 149 equals to 235,826 meters. And our sine b, or our b is DE. So we're like that. So we're like that. Okay. That's a very good, quite good practice because no matter what you use here to get the answer, as long as you have one that is both known and one that is unknown, a ratio that's unknown, you will get the correct answer. So you can, so instead of using this, value, and then you use maybe, because we use this value here to get this value here in the ratio, but if we use dB, we will still get the correct answer. So if you have the time, you can play around and manipulate with it, but you will get the correct answer because it is said that this ratio equals this ratio equals this ratio. That's why you can alternate and use whichever one as long as you have a ratio that has both known and one unknown, and the next ratio that's unknown. You can get any answer you're looking for. Okay, and that is the sine rule. But let's see if we can make any notes on it. If we can make any notes on it. So how do we start this? We say um, determine determine unknown angles. Determine unknown angles on drawing. That's our first step. Number two is determine what triangle you're going to use. Determine triangle that you're working in. That you working in. Number three. Determine the knowns and unknowns in that triangle. So after you determine the triangle you're going to work in, determine the knowns and unknowns with the ratio 4. When I say tick off knowns on ratios, like this here. You tick off the ratios. Then number 5 is manipulate. Manipulate the unknown. Manipulate the unknown to solve. Okay. Then like I said, yeah. So always one ratio with both known values, like this over here, and then second ratio with only one unknown. And then we can also add that you will only use two ratios at a time. So at a time you will only use two ratios, never more than two. Always use two ratios at a time. If you follow these steps, no matter what you are given, you will get what you are looking for. You will get the unknown. Because these steps, they never change. They never ever change. You will always use two at a time, two ratios at a time. You will always only use one ratio that has all the knowns and then one that's unknown to manipulate to get that unknown. And then whenever you start your answering, you determine first all the unknown angles inside on the drawing. Then you determine what triangle you're working in. Are you working with a whole triangle? Are you working with the small triangle within that triangle? You then, once you figure that out, you determine the knowns and unknowns that lay within that triangle that you did here. Um, you tick off the knowns and unknowns, and you manipulate the unknown to solve. I'll bet it's as straightforward as I'm trying to bring it forward, because you will always do these steps. Always. You will always follow these steps.